Good morning, class, and welcome to the session. Okay, guys, so let's get started. So I think last week we have completed our unsupervised, correct? In unsupervised, what all things we have done? We have done a k-means, ECA, and hierarchical clustering, right? So basically, unsupervised is done. Now we will again go back to our supervised. Supervised, and we will see. So this is the agenda for today. Very simple. And the simple agenda is let's discuss Ridge and Lazo. Let's discuss our Ridge and Lazo. The coding part is very simple. You can directly invoke sklearn and do your coding. But let's discuss the theory. So theory part probably might take half an hour or 45 minutes, not more than that. And that's it for today. And then tomorrow we will see something else. Probably tomorrow, the second part, we will start with the new territory, that is the NLP, natural language processing. Okay, but let's discuss about Ridge and Lazo. Now the question over here is, do people remember linear regression? Yeah, take 2 minutes and revise kar do, sir. Or 3 minutes, 4 minutes. Just revise it. Because Ridge and Lazo are the variants of linear. So if linear yaad nahi hai, to Ridge and Lazo mein वैसे भी difficulty आने ही वाली है. Take 5 minutes and revise it, and then probably I'll ask you questions. So that would be a quick revision from my side and from your side also. अपने नोट्स जो भी हैं एक जमाने में बनाए थे वो याद कर लो, देख लो. Revision done? Okay, so fair enough. So Ridge and Lazo, they are basically, you can say, the variants of linear, or you can say a type of linear. Though the concept can be used anywhere, but as of now, let's take it as a type of linear regression. Okay. So Ridge and Lazo are known as your regularization. Regularization or the generalization techniques. They are used to overcome the problem of overfitting. They're used to overcome the problem of overfitting. Now the question is, what is overfitting? I think मैंने class में एक बार discuss किया है, what is overfitting? क्या होता है? What would you like to say? If someone asks what is overfitting, what would you like to say? Okay, something more. याद करो मैंने 2-3 sentences भी लिखवाए थे. या देखो क्या था. Model tries to mimic the data. You get a very high accuracy on the train, less accuracy on the test data, right? So, and what is the actual problem related with overfitting? Model अगर overfit होता है तो क्या problem आ जाती है? Small changes in X leads to large changes in Y. Okay, फिर कुछ और भी बताया था मैंने. High variance कुछ और भी बताया होगा, कुछ और बताया होगा. क्या ये बताया था? Overfitted model needs frequent retraining and retuning. जल्दी retrain करना पड़ेगा because with time whenever the X will change, the Y will heavily change, right? So frequent retraining करनी पड़ेगी. All those were the problem of the overfitting. And guys, please याद रखो, actual problem of overfitting is that retraining only. If the model is overfitted, हर 2-3 महीने में या frequently तुम्हें हो सकता है model को retrain करना पड़े, and retraining will come its own time and cost, right? So it is Ridge and Lazo are used to overcome the problem of overfitting. So if you think, please note down the line, if you think that your linear regression is getting overfitted, if you think that, or if you see that your linear regression model is getting overfitted, then the solution is Ridge and Lazo. Solution is Ridge and Lazo. Solution is Ridge and Lazo. If you think that linear is getting overfitted, you can apply your Ridge and Lazo. Now, Lazo is known as your L1 and Ridge is known as your L2. Or you can say L1 regularization. L1 regularization and Ridge is known as your L2 regularization. L1 and L2 region. So basically, I'm saying generalization or the regularization technique. Generalization. So instead of having an overfitted model which is mimicking your data, I want a model which is a generalized model. It is a general model and not a overfitted model. It is not a overfitted model. Now, how do Ridge and Lazo overcome the problem of overfitting? Okay. So for write down one more thing, Ridge and Lazo can also be used if there is a problem of multicollinearity. If you think there is a problem of multicollinearity or problem of multicollinearity exists. Rituja, can you tell me what is the problem of multicollinearity? Let her think. अरे मैंने कुछ क्वेश्चन पूछा है. You are making your notes. What notes are you making? कुछ लिखा ही नहीं है यहाँ पे. Ridge and lasso can be used when there is a problem of multicollinearity. And what do you think by multicollinearity? What is multicollinearity in linear equation? I am saying what is problem of multicollinearity? Why do we call? एक second. Let me take out call. नहीं पता. You tell me. There is a. Okay. Okay, fair enough. So सबने मिला के एक आंसर दे दिया, and I hope people have recalled what is problem of multicollinearity. So there is a strong correlation among your x variable. When you change one x variable, the another also changes, and thus there is a combined effect on your y variable is very high. Correct? That is the problem of multicollinearity, and if multicollinearity exists, then probably your y predicted y values may be far away from the actual values. बहुत ज्यादा बढ़ जाएंगे शायद. ठीक है ना? So इसको note down करेंगे सब लोग. Next time अगर कोई पूछता है what can be done if you see the problem of multicollinearity, answer is Ridge and lasso. Answer is Ridge and lasso. Note down one more line. Lasso can also be used for feature selection. Lasso can also be used for feature selection. But Ridge cannot be used. Ridge cannot be used for feature selection. Ridge cannot be used for your feature selection. And please ये line याद रखना that lasso can be used for feature selection. Ridge cannot be used. Using Ridge, you cannot do your feature selection. What is feature selection? तुम बताओ. Feature selection we give? Which values? तुम बताओ. What is feature selection? Or let me change my word, feature importance. Zubair, तुम बताओ. क्या नाम है उसको? हाँ, तुम बताओ. What is feature importance? तुम्हारी तो थ्योरी अच्छी रहती है, बताओ. फिर से रिपीट करो सेंटेंस. तुम यस, उसने सही बताया। आई थिंक ये आइडिया सबको क्लियर है, बट सेंटेंस वाइज सिर्फ एक ही ने सही बताया। फीचर सिलेक्शन टेल्स मी दैट out of n number of x variables, which x variables are most important and which are less important. Remember feature importance decision tree random forest कितना किया था हम लोगों ने? So basically Lazo can tell you which variables are important and which are not important, right? Or which are significant or which are influencing your y and which are not influencing your y, which can be ignored also. Yes. So later on we will see. But as of now, let's enter into this territory. See the main use of Ridge and Lazo. Ridge and Lazo are, please remember, they are regularization or the generalization technique. They are used to overcome the problem of overfitting. Now let's see how Ridge and Lazo are used to overcome the problem of overfitting and how do they actually work. Model. मेरे मुंह से कभी कॉस्ट फंक्शन वर्ड सुना? कॉस्ट फंक्शन नहीं सुना, आज शायद पहली बार सुन रहे होगे, बट यहां से वेरी फ्रीक्वेंटली सुनोगे. So cost function is also known as your loss function. वो डेटा साइंटिस्ट ही गया जिसने कॉस्ट फंक्शन सुना है, ऐसा समझ लो, ये इतना इंपॉर्टेंट है. ठीक है. मॉडल. सो लेट मी से लीनियर मॉडल और लीनियर रिग्रेशन. Ridge and Lazo. In linear regression, your cost function is MSC. In ridge regression, cost function is MSC plus lambda summation beta square. In Lazo, it is MSC plus lambda summation mod beta. ये टेबल एक ड्रॉ कर. अच्छा, remember when we were doing linear regression, मैंने क्वेश्चन पूछा था, why do we only take square? Positive and negative. हाँ, and उसके बाद मैंने बोला why only square, why not power 4, why not power 6? याद आ रहा है? आज वो क्वेश्चन आंसर हो जाएगा कि सिर्फ स्क्वायर ही क्यों लेते हैं, पावर 4 क्यों नहीं, पावर 6 क्यों नहीं, पावर 8 क्यों नहीं. अभी के लिए सिर्फ इतना नोट डाउन करो. इन लीनियर रिग्रेशन योर कॉस्ट फंक्शन इज एमएससी. In ridge regression, your cost function is MSC plus lambda summation beta square. In Lazo regression, it is MSC plus lambda summation omega t. What is omega? No. See, don't get confused with it. Lambda over here is a scalar. It is just a number. It is just a number. अभी समझ में आ जाएगा. But don't get confused with all those omega and other. It is just a scalar. ठीक है. Now, since I have used the word cost function and loss function, let me talk little bit about cost function and loss function. You will understand it much more when we do a neural network. Okay, you will understand it much better because entire neural network will work on your cost and the loss function only. Okay, so cost and the loss function. So basically, cost function is also known as your loss function. So whether you say cost or loss, it is one and the same. And then later on, I'll introduce few more cost and loss function. So what is MSC? MSC is nothing but your mean square error. सबको याद आता है? Mean square error. Let me do one thing. Let me just revise what is mean square error. Me revising means you will revise it. Let me say this is your actual value and this is your predicted value. बिल्कुल वैसे ही एक नंबर डालना जैसे तुम लोग के मॉक में पूछा था. So let me say actual value is 190, predicted is 200. Actual value is 250, predicted is 240. Actual is 400 and predicted is 395. So this A is your actual, P is your predicted. So how would we find the MSC? कैसे निकालेंगे? पहले क्या निकालेंगे? पहले एरर निकालेंगे. Okay, let me add a column for error. So what would be the error? Actual minus predicted. So 190 minus 200 minus 10. This 10, 5. Then I'll take a square of error. So minus 10 becomes 100, 10 becomes 100, and this 5 becomes 25. Then sum, इसका summation कर लेंगे 2 to 5. Then MSC would be 225 divided by 3, whatever may be the. So this is your MSC, right? This is your MSC. Now, basically, we know that lower the MSC, better is the model. Lower the MSC, better is the model. Okay. So MSC is a cost function in your linear regression. So remember one thing. So for example, if you remember the linear regression theory, जो जैसे मैंने पढ़ाई थी, suppose करो these are your points, right? So what I said that you draw any line, you cannot connect all the points. कोई भी line draw करो. So what I can do is I can find the MSC. I can find the MSC for each line, or you can find the MSC, or let me say, out of so many solutions which are existing, you choose the solution, or you choose the solution where MSC is least. Where MSC is least. You choose the solution where MSC is least. And because I'm saying lower the MSC, better is the model. You choose the solution where MSC is least. Now the question is why हम MSC पे ही focus करते हैं. Suppose अब मैं एक नया concept डाल रहा हूँ. If you understand it, very good. If you don't understand it, then also not a very big problem, because I would be discussing this concept again in neural nets. Suppose karo. What is MSC? MSC, in MSC, do you notice I have taken a square? And purposefully I have added numbers which is minus 10 also and plus 10. So do you notice at minus 10 and at plus 10, for both of them the value is 100? So MSC is a square function, and any square function would always be like this. कोई भी स्क्वायर फंक्शन हमेशा ऐसे होगा. सपोज करो यहाँ पे x एक्सिस, सपोज करो ऐसा ओरिजिन है. So for minus x also, so over here the values are in, so in this region the values would be in minus, and in this region the values would be in positive, but the y value तो तभी भी same रहेगी. So the square function would always be something like this. Now, अब सब लोग ध्यान देंगे, एक नया चीज डाल रहा हूं मैं, MSC. So what is MSC? MSC is acting over here as your cost function, or you can say loss function. And I'll say best solution is where MSC is least. जहां पे MSC सबसे कम होगा वही सबसे अच्छा solution होगा, because MSC is representing your error, mean of your square. So MSC represents your error. So best solution is where your MSC is least. Now, अच्छा, do you remember that K means कैसा था? K means was your iterative process. Iterative process था ना? Iterative means it runs number of times. Suppose करो, for time being, when I'm talking about the cost function, let me say out of these many solutions which are existing, I want to select a solution where my MSC is least. So you run your model for first time. तुमने मॉडल को एक पहली बार रन किया, okay? And the cost function you are using is MSC. The cost function you are using is MSC. Now, when you are running it for the first time, you found the MSC. So point A represents the MSC when you have run your model for the first time. And imagine this whole part is not visible. It is not visible to you because this red part is created when your model runs for number of times. तुमने अभी सिर्फ पहली बार मॉडल रन किया, you have run your model for first time and you got just one value of MSC. आज तुम्हें समझ में आएगा लाइफ में एम क्यों जरूरी होता है. और let me say you ran your model first time and you just have 1 point. You ran your model first time and you have just 1 point. So you are standing at point number A and you don't know in which direction to travel. You don't know whether I should travel in this direction or in this direction. इसको कुछ ऐसा समझो, सपोज करो तुम एक माउंटेन से उतर रहे हो. You are climbing down a mountain. तुम point number A पे हो and you want to reach the point number B. And this is a mountain. And imagine it is very foggy. So if it is foggy, then this entire portion is not visible to you. तुम्हें दिखता नहीं है. You cannot see where exactly the point B is and how far the point B is. कितना दूर है नहीं पता, पर है वो पता है. I know where the point. I know that point B would be existing, but where it is, I don't know. And you don't even know that in which direction should I travel. Should I travel in this direction or should I travel in this direction to reach the point? यहाँ पे mountain नहीं, valley आ गई है. So basically what will you do? Suppose you have some instrument, तो तुम क्या करोगे? तुम एक point, एक step ऊपर लोगे, इस तरफ लोगे, and you will measure the height. If the height is increasing, you will come down. So you move towards, let's say, point number A1, and you measure the height between A1 and A. If the height is decreasing, it means you are in the right direction. And फिर तुम उस direction में चलते रहोगे. At point number A2, again you will measure the height. You have some instrument. And if height again decreases, if you compare the height between A2 and A1, and the height again decreases, you continue your journey. So over here, what I'm doing, I'm measuring the height, but over here, what I'll do, I'll measure my MSC. So again, come back to this point. So at point number A, you don't know in which direction to travel. So what do? You will use the concept of your dy by dx. What is dy by dx? Dy by dx is nothing but your slope, or you can say your gradient. So you take the step towards your A1. At A1, you will measure the slope. And if slope is decreasing, it means you are in the right direction. If the slope is decreasing, it means you are in right direction. Then you take a step at A2, then at A3, then at A4, and you continue your journey. At, let's say, point number AN or point number B, you have reached the bottom, and then again, if you move upwards, then the slope will start to increase. When the slope starts to increase, it is an indication that your best point has been left behind. So, starting at point number A, you cannot see the best point, and you did not even know how far the best point is. But तुम्हारे पास क्या था? You knew your aim. Your aim was to reach the point where your slope is or where your error is least. Okay. So at point number A1, so imagine ये देखो ये MSC है. So A1, A2, A3. So when you travel from A1, A2, A3, do you notice that MSC will keep on decreasing? MSC decrease होता जाएगा. And we are saying lower the MSC, better is the model. So if MSC is decreasing, it means I am getting better and better. So after your point number B, when you move towards your B1, the errors will start to increase. So it would be an indication that my best point has been left behind. Okay. So this is known as your cost function. And what did I use? I used my gradient descent. So gradient descent is an, isko note down karo. Gradient descent is an my optimization algorithm. Gradient descent is an optimization algorithm. It is an optimization algorithm to reach the point where error is least. Optimization algorithm. MSC is the cost function. Gradient descent is an optimization algorithm. Optimization algorithm to reach the point where error is least. अब जब next time तुम्हारा वाइवा होगा ना तो cost function क्या है, gradient descent क्या है, वो सब पूछूंगा. किसी को बोलूंगा डायग्राम बना के समझाने के लिए. ठीक है. So gradient descent is an optimization algorithm. It is used to reach the point where my error is least. Again, let me recap it. So I know it is a little difficult topic. So for example, what is my aim? My aim is to reach the point where my error is least. So I find the MSC. So let me say at the starting, you are at point A and you are in darkness. You don't know whether to move in this direction or whether to move in this direction. So how do you find the direction? You find the direction by doing your dy by dx. So dy by dx is nothing but your gradient. And if you move in this direction, A1, A2, whatever, your slope will keep on decreasing. So this gives you the direction indication that you are moving in the right direction. At every point, you find the MSC. And you compare the MSC with your earlier point. If MSC is decreasing, it means you are in the right direction. और तुम वो direction लिए रहते हो, चलता रहता है. Till the time, let me say you reach the point B. And then when you move towards the B1 or B2, it tells you that your slope is or your errors are increasing. It means your optimum point has been left behind. So again, you come back and you reach to this point. Now come to this thing. So in linear regression, your cost function is your MSC. In ridge regression, your cost function is MSC plus lambda summation beta square. In Lazo regression, it is MSC plus lambda summation mod beta. Now the question is, what is beta? Beta to sabko pata hai. Remember, y is equal to beta naught plus beta 1 x1 plus beta 2 x2 plus so on and so forth. Okay. So you are taking the summation of the beta square. What is mod beta? Again. So remember, the beta value can be minus also. The slopes can be minus also. But you are ignoring the minus sign. You are taking the mod beta. You are taking the mod beta. Now the only question is, what is lambda? Lambda is a scalar. It is a scalar, but normally less than 1. It is normally between your 0 to 1. ये weightage decide करने की काम आता है. So if you are multiplying by 1, the beta value will remain same. If you multiplying it by less than 1, the beta values will decrease. And if the beta will decrease, the weightage will decrease. The weightage will decrease. So what is the main aim of a ridge and lazo? Main aim of ridge and lazo is to overcome the problem of overfitting. याद आता है सबको? Main aim क्या है? Overcome the problem of overfitting. Now, tell me one thing, guys. What is MSC? MSC is the representation of your error in linear regression. MSC represents the error in Linear regression. Correct. And what is the range of MSC? 0 to infinity or 0 to something? So will people agree when people are saying 0 to something, it means they are agreeing that it is a positive number. Positive to high. Now, what is the error in your ridge? Error in your ridge is MSC plus lambda summation beta square. Correct? इतना ही है ना? क्या लिखा है यहाँ पे? Ridge में lambda summation beta square. ठीक है ना? What is the error in Lazo? MSC plus lambda summation mod beta. एक काम करते हैं वापस यहाँ से delete. Okay. So MSC plus lambda summation beta square हो जाएगा ridge में, and MSC plus lambda summation mod beta हो जाएगा Lazo में. What is MSC plus lambda summation beta square? This is nothing but error in ridge, am I right? And this is nothing but your error in Lazo. This is nothing but your error in Lazo. What is error in linear? वैसे चाहूँ तो मैं एक लाइन ही बता सकता था, बट फिर भी बैकग्राउंड बिल्ड करके बता रहा हूँ. Error in linear is MSC. अच्छा, everyone has agreed that MSC is a positive number. Okay, and I have said lambda value मैंने ली है. Lambda value I have taken between 0 to 1, though it can be anything, but as of now I am taking between 0 to 1. So lambda is also positive, let's say. And what about summation beta square? This would also be positive. Summation mod beta positive ही होगी. So can I say MSC plus lambda summation beta square is greater than MSC? हाँ या ना? And similarly, I can say MSC plus lambda summation mod beta would be greater than MSC. Am I right? So what can I say? I can say error in ridge is more than your error in linear. Am I right? Similarly, I can say error in Lazo is more than your error in linear. Correct? And now tell me, what is overfitting? What is overfitting? Overfitting is a scenario where your errors are less. वही होता ना? So what I'm doing, I'm saying error in ridge are more than error in linear. Error in Lazo are more than error in linear. So if error is more, chances of overfitting will automatically reduce. अगर errors ज़्यादा हैं, तो model overfit तो नहीं होता, और chances will reduce. So what is overfitting? Overfitting is your model is having very less error. Now what we can see that in ridge the error is more than your error in linear. In Lazo your error is more than in your linear. Write down one line. If errors are more, then chances of overfitting will automatically reduce. If errors are more, chances of overfitting will automatically reduce. If errors are more, chances of overfitting will automatically reduce. If errors are more, chances of overfitting will reduce. Now, did you guys notice one thing? In ridge and Lazo, I have purposefully, जानबूझ के मैंने errors को बढ़ाया है. I have purposefully increased the error. And why did I increase the error? So that problem of overfitting is vanished, or overfitting is getting reduced. So I am write down on this line also. In ridge and Lazo, we are purposefully increasing the error. नॉर्मली हम लोग एरर डिक्रीज करना चाह रहे हैं, यहाँ पे पर्पसफुली बढ़ाया गया है. In region Lazo, we have purposefully increased the errors. And if errors are more, chances of overfitting will reduce. We have purposefully increased the errors. So, MSC plus lambda summation beta square. This is in your ridge, and MSC plus lambda summation mod beta is in your Lazo. Lambda summation beta square, it is known as your penalty function. Penalty पता है? Fine लगाना. It is a penalty in your ridge. अगर कोई पूछता ridge में penalty क्या है? Lambda summation beta square. Penalty इसलिए बोलना because ये purposefully error बढ़ा रहा है. It is purposefully increasing your error penalty. Similarly, lambda summation mod beta is your penalty in Lazo. हमने एक penalty लगा दी. Penalty means purposefully increasing the error. Lambda summation beta square and lambda summation. If errors are more, chances of overfitting are reduced. कभी भी तुम्हें लगे तुम्हारा मॉडल ओवरफिट कर रहा है तो एरर्स बढ़ा, मॉडल एंड ओवरफिट के चांसेस रिड्यूस हो जाए. इतना क्वेश्चन क्लियर है? Now come to the next part. What was the next part? There were two more things which I have discussed with Ridge and Lazo. What were they? So I said that Ridge and Lazo can be used to overcome the problem of overfitting. To discuss कर लिया ना? Multicollinearity. Multicollinearity and Lazo can be used for your feature selection. Overfitting वाला part तो discuss कर लिया. Now let's discuss how Ridge and Lazo can answer this problem also, and how they can be used for a feature selection. So Lazo can be used for feature selection, Ridge cannot. Now, suppose there is high correlation among x1, x2, x3, x4 and x5. Suppose there is a high correlation among your x1, x2, x3, x4 and x5. Now suppose if your x1 increases by 1 unit, what would be the impact on your y? अगर x1 1 यूनिट से इंक्रीज करेगा तो y कितने यूनिट से इंक्रीज करेगा? 6 यूनिट. But when x1 will increase, x2 will also increase, and increase in x2 will increase, result in 7 unit change in this. And then x3, x1, x2 is increasing, then x3 will also increase, and x3 की वजह से 11 unit के change आ जाएगा. Similarly, your x4 will increase by 1 unit, then it may have your combined effect of your 3.5 unit, and then your x5, it may have impact of your 8 units. So basically what will happen that your change in your y may not be only 5 units or 6 units. Change in your y may be a combined effect of all these numbers. ठीक है ना, एक multiplier effect लग जाएगा. So if there is a strong correlation between your x1, x2, x3, x4, x5, then change in one x variable results in a large change in your y variable. Now, consider if by some hook or crook, by doing something, you are able to write this equation something like this. (1.5x2 plus 3x3 plus 0.5x4 plus 9x5. Let me say. Okay, let me say by doing some trick or some magic or whatever, you are able to write the equation A as equation B. Then will people agree that problem of multicollinearity is getting diminished? हाँ या ना? हो सकता है ना diminish हो रही हो. But what does your brain say? अगर multicollinearity अच्छे से समझ में आया है तो इसका आंसर दे दोगे. So out of two equations, equation A and B, where do you see the problem of multicollinearity would be less? And why? Results are decreasing x variable. So उससे क्या होगा? Please थोड़ा सा और explain करिए. Maybe you are in the right direction. Y would be affected, but little bit less. Okay, I think what you're saying is right only. देखो, what is the problem of multicollinearity? The real problem is that when you change your x1 or x2, the combined effect on your y is very high. Over here, do you notice that most of the x variables have been diminished? पहले ये 6 था, यहाँ पे 2 कर दिया, 7 का 1.5 कर दिया. These are just numbers for representation purpose. 11 का 3 कर दिया, 3.5 का 0.5 कर दिया. यहाँ पे थोड़ा सा increase हो रहा है. So now if you change x1, the effect on your y would be your 4 units. When x1 changes, x2 will change, but the impact would be only 1.5. And then your x3, the impact would be your how much? 3. And for x4 का impact कितना होगा? 0.5. And x5 का impact कितना होगा? 9. So over here, if you add these numbers properly, कितना आ जाएगा? 9, 10, 13, 14, around 15 कुछ आ जाएगा? Around 15. And over here it was how much? 13, 23, 24, 34. Around 34, let's say. I'm not done exact calculation. So do you notice what was problem of multicollinearity? Problem of multicollinearity was that a small change in x will result in very large change in your y. Can you notice? Real problem was small change in x results in large change in your y. So if you compare A and B, the problem of multicollinearity is getting diminished in your A, getting diminished in your B compared to your A. Change in x is having change in your y, but the amount or the magnitude of change is limited. It is limited. और ऐसा क्यों हुआ? ऐसा इसलिए हुआ because you have shrink your betas. You have shrink your betas. Now note down one line. In Ridge and Lazo, the betas get shrink. In Ridge and Lazo, betas get shrink. Shrink means they get diminished. They get shrink. That is your diminished. And that is why they are able to solve the problem of multicollinearity. Betas को shrink कर दोगे तो problem of multicollinearity would be contained because the combined effect of your x on y would be limited. So एक लड़के ने सही आंसर दिया. Good observation. अच्छा, now there was one more sentence. Theory comes to an end almost. There was one more sentence that Lazo can be used for feature selection and Ridge cannot be used for your feature selection. Let's discuss that part also, and then my job is done. मेरा आज का काम खत्म हो जाएगा. तुम लोग का स्टार्ट हो गया। उसके बाद मैं घर भी जा सकता हूँ, चाहो मेरी तबीयत ठीक नहीं है, लेकिन वो तुम लोग का प्यार है यहाँ तक खींच लाया। वरना आना नहीं चाह रहा था मैं। अच्छा, नाउ लेट्स सी दैट पार्ट. योर लाजो can be used for feature selection. And guys, again, I'm stressing Lazo can be used, which cannot be used. इसको याद रखना. Don't get confused. Lazo can be used for feature selection, which means it can tell you which X features are important. Now, suppose करो ये equation B को हमने अगर ऐसे लिख दिया. I use some methodology and I am able to write this equation something like this. Suppose करो. This is your equation C. So by using some technique, I have the equation B can be written something like this. Now, can this equation be used for your feature selection? यार ध्यान से देखो, बताओ. एक हिंट देता हूँ. Yes, it can be used for feature selection. कैसे? Can equation C be used for feature selection? Answer is yes. तुम लोग को बताना है कैसे. We can add. We can add 1x4 and subtract 1x4. नहीं नहीं, इतना कॉम्प्लिकेट क्यों कर रहा अपनी लाइफ को. बड़ा सिंपल सा आंसर है. Both the okay, and then yeah, so this time उसने सही आंसर दे दिया. उसका आंसर समझ में आया सबको? समझ में आया? सी इक्वेशन सी को हम क्या ऐसे लिख सकते हैं? y is equal to x plus 2.2 x1, 2.2 x1 plus 4 x3 plus 11 x5. So will people agree that equation C and D are same? C and D same है. Why? Because 0x2 and 0x4. The beta value of x2 and x4 are 0. It means even when the value of x2 is 1 million, the impact on your y is, there is no impact on your y. तुम x2 and x4 की कोई भी वैल्यू ले लो, y पे तो कोई चेंज नहीं आने वाला. Correct? So it means I can ignore my x2 and x4. So out of five variables which I had initially, I can build my model using only 3 variables. So it means what I have done? I have done my feature selection. ऐसा इसलिए हो रहा है because if the beta value becomes 0 for any x variable, that x variable is insignificant. Now make a note. In Lazo, few of the beta values may exactly become 0. In Lazo, few of the beta values may exactly become 0. In Lazo, few of the beta values may exactly become 0. Hence, Lazo can be used for feature selection, and which cannot be used for feature selection. In Lazo, few of the beta values may exactly become 0. Hence, Lazo can be used for your feature selection, and which cannot be used for your feature selection. And that's it for the theory part. एक तो PTMS और दूसरा इसको भी आई थिंक ये डेटा शायद डायरेक्टली चैट में भी जा सकता है, मैंने एक दिन देखा था। जैसे मैंने ईमेल कर दिया था। आई थिंक ये मैं चैट में आ रहा है, चैट में इट इज गेटिंग अपलोडेड गाइस। देखो चैट में आया डेटा, सबको दिख रहा है? डाउनलोड इट प्लीज, सो दिस इज अ बेटर ऑप्शन। सो थोड़ा सा टाइम बच जाएगा। अच्छा, अब सब लोग प्लीज मेरी बात को ध्यान से सुनो। तुम लोग को करना क्या है, तुम लोग को करना है, मुझे कुछ नहीं करना। वॉट एवर हैज टू बी डन हैज टू बी डन फ्रॉम योर साइड। मेरा काम अब वैसे भी खत्म है, तुम सब लोग होशियार हो गए हो, ठीक है। करना क्या है, दिस इज अ डेटा सेट, not many records, 4,200. You have worked on more than these many records. Number of columns are little more, 378. Columns थोड़े ज्यादा है, ठीक है, बट उससे कोई फर्क नहीं पड़ता। I'll tell you which is your target variable. Target variable is your y. उसका नाम ही y है तो target ही होना। So this is your y variable. So this data is related to your auto industry, and this y is your emission, जो pollution करता है ना, उससे related ये data है। And all x1, x1, x2, x3 have been masked. So real name देने की बजाय उसने x1, x2, x3 डाल दिया। So what you guys need to do is, and I hope people understand that ID column, they will remove it. It is just a unique identifier. So the data may look very big, but I don't think there is much data cleaning required. Much data cleaning required. You can use your label encoder, whatever you think. I will give you half an hour. 9:51 हुआ है, 10:20 या 10:30 maximum. Build your linear regression. मेरी बात को लोग ध्यान से सुनेंगे. Build your linear regression. And after building your linear regression, what people will do, they will find their R square. They will find their adjusted R square. And then find MSC on train and test. Train and test दोनों पे. MAPE on train and test. MAE on train and test. And your RMSC on train and test. R square adjusted R square only on your train data, but rest everything on your train and test, train and test, train and test. Possible है? सबको याद है मॉडल बिल्ड करना? Half an hour का टाइम काफी है, and time I'm giving you, it is 9:52. You take your time till 10:22. Half an hour. Half an hour. I'll not take any question and I'll not answer any question. सब लोग अपना अपना करेंगे, कोई किसी का देखेगा भी नहीं, खुद अपना दिमाग सर्वाइव करो. Build your linear regression. Build it and then I'll tell you how to build your region also. ठीक है? Those who are in online guys, are they clear with the problem statement and the requirement?
Yes, sir.
Yes, okay. Please give a try. And after 30 minutes, I will ask everyone to share their MSc, RMSc, both for train and test training. चालू हो जाओ. सुबह से कुछ करा नहीं, वैसे भी तुम लोग ने बैठे बैठे सुन लो. अब कुछ मेहनत कर लो. Give it a try, guys, and then we'll see. Yeah, please, please. with data cleaning taking huge amount of time. Is data cleaning very problematic? Nulls है क्या? नहीं है? I think सबने वही लेबल इनकोडर यूज कर दिया होगा. और सही. ठीक है, लेबल इनकोडर can be used directly, no problem. कहाँ तक पहुंच गया संजय? क्लास क्या मैं नीचे जाके चाय पी सकता हूँ विद योर परमिशन? थैंक यू सो मच. तुम लोग लगे रहो, ठीक है? Fifteen more minutes and answers should start to pour. ठीक है. And I would be back in 5-10 minutes.
Adjusted. Range of information. This guy can check. Check. चेंज केलं का हा तेवढंच येतो ट्रेनचा आरएमएससी पण नीचे सांगितले एमएपी मी नाही का
So what's the MSc? ट्रेन टेस्ट MSc आया? बोलोगे नंबर्स बोलोगे गाइस चैट पे डाला है MSc on test is this much, MSc on train is this much. So do you see a very big difference between MSc and train and test? तो क्या लगता है मॉडल ओवरफिट हो गया? मॉडल बनेगा तब तो ओवरफिट होगा ना। कुछ लोग ने उससे बनाया नहीं। So let me have a round. जब मैं राउंड लेता हूँ तभी एक्चुअल चीज।
तुला तेच म्हणलं इथे पण मायनस अरे टेक्स्ट स्टोर जास्त येते ट्रेनिंग भरपूर
कितना आ रहा है? चैट पे डाला है? So train pet is around 66 and on test it is plus 19. It means almost infinite. ठीक है. What about MAPE? MAPE on train is 4.96, which is 5%, and MAPE on test is 2493. It is in some lakhs or in crores. So देखते हो. And lower the MAPE, better the model, or lower the MSc, better is the model. So do you notice on train the values are good, but on test the values are huge. So will people agree that model overfit? Model overfit होता हुआ दिखता है? Let me do one thing. Let me also build it. Okay, let's do one thing. जल्दी से कर लेते हैं. Any null values?
No.
No null values. Okay. Can someone put the code for data cleaning? और data cleaning का code को डालो प्लीज चैट पर. तुम डालो. Any one person. नहीं तो पहले मैं खुद भी कर सकता हूँ, कोई बड़ी बात नहीं, बट अगर तुम लोग डालोगे तो डाल दिया. डेटा क्लीनिंग को ज्यादा नहीं है, राइट?
एक ही कॉलम था
सैम्पलिंग का कोड भी डालो। ट्रेन को 1 से देखिए कोलन -1 तक क्यों गया? 1 कोलन, आई थिंक यहाँ तो चले जाओ 1 कोलन कोलन एंड 1 कोलन कोलन चेंज करो प्लीज। And train Y is this makes sense. So now df train dot head. Let me just see the first record. Train underscore x. Let me see. Okay, so it has 376 columns. Columns till your 385. Okay, and let me just see train Y. Train Y dot head. इसमें क्या आ रहा है? इसमें सिर्फ एक कॉलम आना चाहिए. That is fair enough. Okay. Now let's go for a model building from sklearn dot linear model. Import linear regression. Linear regression equal to linear regression. एक इंस्टेंस क्रिएट कर लिया. Linear regression dot fit. And what I can do is I can just pass my x and y. Model bit. And instead of it, if I do the score, I'll get my R square. So from R square 0.60. So from R square, I don't get an idea whether model is overfitted or not. So R square doesn't seem to be very high. Okay. But what about adjusted R square? If you want, you can find your adjusted R square also. 0.6 से कम ही आना चाहिए. So let me say एक फॉर्मूला डाल देते हैं. R square is equal to R square is this much. And what is value of k? K is equal to df in x dot shape. And I'll say 0, no, not 0, but 1, right? 1. And I'll take it as 0. And I'll take it as 0. Then what I'll do, I'll say adjusted R square is equal to 1 minus R square. SQUARE square into n minus 1 divided by n minus k minus 1. So what is the adjusted R square? Around 0.55 आ रहा है. तुम लोग का कितना आ रहा है? 0.53, 0.54. Fair enough, not an issue. Let's do one thing. Let me say prediction on the train data and prediction on your test data. So for doing the prediction on the train data, what I'll do, I'll say this dot predict, and I'll pass my train x. And for doing the prediction on my test data, I'll pass my test x. Okay. Error train, error test. So what is error? Error is nothing but actual minus predicted. So when you're doing prediction on train, the actuals value will come from your df train y minus your predicted values. So these are your predicted value. Similarly, I'll copy this thing, put it over here, and train y की जगह कर देंगे test y, and predict train की जगह कर देंगे test, predict test. I hope people are clear till this point. Now let's find MSC train. MSC train. What I'll do, let me import your NumPy. If you have already imported NumPy, you can ignore it. Import NumPy as NP. So I'll say NP dot mean and NP dot square. Square of what?
Train.
Error. Similarly, इसको copy करेंगे, यहाँ डाल देंगे. And wherever you have train, convert it into test. Now let's see our MSC tree. 63 makes sense. MSC test. Can you notice MSC test is E plus 18? E plus 18 means ये number कुछ ऐसा है. यहाँ से 1 हटा दो तो 1 2 3 4 5 6 7 8 10 11 12 13 14 15 16 17 years. So this is your MSC. Can you notice ये कितना करोड़ है या क्या है? 1 tens 100 1000 10,000 lakh 10 lakh crore 10 crore 100 crore 1000 crore 10,000 crore 1 lakh crore 10 lakh crore 100 lakh 1000 lakh 1 lakh 1 lakh 1 lakh और पता नहीं 1 crore 1 पता नहीं, शायद मुझे उतनी काउंटिंग नहीं आती. ठीक है, but do you notice it is a very big number, and we know that lower the MSC better is the model. So train में इतना कम and test में इतना ज्यादा. What does this mean? This means model has overfitted. Am I right? So इसके आगे हम लाइन देंगे MSC in test is very large compared to MSC in train. So model has fitted. Model overfit. And similarly, what I can do is I can find the MAPE. MAPE train and MAPE test. So for MAPE, what do I? Error, percentage, absolute and mean. So NP dot mean and NP dot absolute, error,
Train.
error train into 100 divided by
Test one.
DF train y.
Train.
And बस इसको कॉपी कर लेंगे या नीचे डाल देंगे और जहां पे ट्रेन था वहां पर कर देंगे टेस्ट, जहां पे ट्रेन था वहां पर कर देंगे टेस्ट. Now let's see MAPE train. Around 5% or little less than 5%. अब देखते हैं भाई साहब यहाँ पे कितना. Can you notice? It's a very big number. 1 tens 100 1000 10,000 lakh 10 lakh crore 3 crore 59 lakhs. Very high MAPE. And normally MAPE अगर 100 से ऊपर चला गया, it means it's a very high error, right? Because it is a percentage error. So model has overfit. So from your train also, and if MSC is high, probably RMSC is also going to be high, right? And if you want, you can find your MAE also. So I'm not finding the MAE. Probably people can find on this one. But now I'll give you 5 minutes. Suppose करो एक crime हो गया है. Crime क्या हुआ है? Model overfit हो गया. अब पता लगाओ ये overfit हो क्यों रहा है. Investigate करो. What could be the likely cause of overfitting? Everyone agrees model has overfitted. Now investigate why it has overfitted. अब तुम्हारा data science का दिमाग यहाँ पे लगने वाला है. Problem तो हुई है, पर क्यों हुई है? उसको pin down करो. और जब प्रॉब्लम पिन डाउन हो जाएगी तो सोल्यूशन आ जाएगा अपने आप. मैंने बोला पिन डाउन करो, इट मींस यू हैव टू प्रूव इट थ्रू डेटा। फॉरेंसिक जांच करो उसकी, बाल की खाल निकालो। इतना मॉडल तो एक बच्चा भी बना लेता। बच्चे को डेटा साइंटिस्ट में कुछ तो फर्क होना चाहिए ना। अब पता लगाओ what would be the likely cause of such a high MSC in test? कहाँ पे दिखता है? क्या दिखता है? कुछ आइडिया तो तुम लोग मेरी थ्योरी से बता सकते हो। मेरी जनाब की थ्योरी है। कुछ इसमें क्या देखो क्या मल्टी को मल्टीकोनालिटी है क्या? अच्छा, now see, basically how do you investigate? The error in your test are large. Error large होंगे. So if errors are large, it means the predicted value should also be large. Predicted value should also be large. जरा देखो तो सही predicted values कैसे हैं in train and test. एक काम करते हैं, सबसे पहले हम डीएफ ट्रेन नेक्स्ट लेते हैं। इस पे कोरिलेशन मैट्रिक्स बहुत ज्यादा कॉलम्स है तो शायद थोड़ा सा देखने में प्रॉब्लम आएगा। इस डेटा को तो यहाँ पे तो देखने में थोड़ा सा इशू आ रहा है मेरे को। ये कुछ में नैंस क्यों आ रहा है? अच्छा ठीक है, एनीवे इसको हटा देते हैं, इसको ऐसे देते हैं। See guys, now so I am getting problem with this thing, so let's do one thing. So df train y, not, अच्छा मैंने train x पे किया था ना, so I should have actually done on the entire thing. अब यहाँ पे देखो सब लोग प्लीज, df train and let me say dot y. Okay, so in df train y, so basically what is the range of your y variable? Range of your y variable is minimum is 72 and maximum is 265. Minimum 72 and maximum is 265. So how many records I have in my data? एक मैं train Y पे भी नहीं, I want to do it on the entire one. Let me say DF. One second. Let's do one thing. Let me say DF dot Y, not even on train. Let's do on the entire one. So minimum is 72 and maximum is 265. Out of this data, DFY, something will go in train, something will go in your test. एक चीज notice करो that all your entire 4,000 records, their range is from your 72 to 265. So within 200 points में सारे points आ रहे हैं, within the range of your 200. Now let's do one thing. Let me say predicted train. Let's see what is the predicted train dot maximum value. इसकी maximum value कितनी है? 116, 169. इसकी minimum value कितनी है? 69. Let's do the same thing for our predicted test. इसकी maximum value देख रहे हो? And so what I know that I know my target variable cannot be more than 265. And if you are predicting something like this much, it means there is a large error. And if you take a square, the error would be even more compounded. Similarly, if I do something like this, if I take the minimum, can you notice? What is the minimum value? Minimum value is only 72. And the predicted value is somewhere in crores. Obviously, it is in minus crores, but it is a problem. So when you are taking your MAPE or when you are taking your MSc, the negative, there is no role of your minus sign. Square में भी minus sign हट जाएगा और MAP में भी absolute values. So do you notice because of these things, since in your test data, the predicted values are very far away from your actual. That is why you are getting this problem. इस वजह से problem आता है, ठीक है? Now, if I can do something like this, predicted test पर describe run होगा. Let me say describe run होगा कि नहीं होगा? Describe run नहीं हो रहा. Okay. Predicted test greater than, let me say 300 or greater than, let me say 265. Do you notice, guys, that there is only one value which is more than 265? इसको कुछ ऐसे देखो, suppose अगर मैं यहाँ पे बोलूँ greater than 10, so you will not get so many values. So when I say 265, so it means I am selecting all those values for which the prediction was more than 265. Can you notice there is only one value which is causing this problem? सिर्फ एक ही ऐसा नंबर आ गया है जो इतना प्रॉब्लम क्रिएट कर रहा है. Similarly, if I say something like this, what is the minimum value? Minimum value was 72. Let me say less than 72. And there is just one value which is very less. But these values are so big in the scale that they are dragging the results. पूरे result को drag कर दिया. Because these are very high numbers. These are very high numbers. Similarly, if I can do something like this. So this is just for your investigation purpose. If you want to investigate, let me say how many values are greater than 265. None of them. Less than how much? 72. देखिए कितने 72 से कम है. So there are only two values, 69 and 71. And do you notice they are just little less than 72? है ना? They are close. So remember I have said that I would be having errors, but at the same time I do not want large errors. Large errors errors होंगे because not all the points can follow the same thing. Now we come to know that high MSC and high MAP are coming because you are doing, you are having some very large predictions on your test data. Now let's try to find इतना large prediction हो क्यों रहा है, इतना large prediction हो क्यों रहा है, किसी ने find करने की कोशिश करी? अच्छा, remember this thing, अभी मैंने जो equation create करी थी, something like this. Let me share the screen. Remember something like this, y is equal to beta naught plus this thing. Some large beta values may be causing this problem. Some large beta values may be causing this problem. Let's try to find out कि betas के range क्या है. So how can I find the betas, guys? Intercept. So what I'll do? Intercept or coefficient? Coefficient. ठीक है ना, इसको हम एक लिस्ट में डाल देते हैं. So देखो, there can you notice there are some large beta values आते हुए दिख रहे हैं. Ignore the sign and do you notice large beta values? Notice करते हो? Large beta values. And not only for just one x value. There are so many large beta values. So it means when you will change this variable, the impact on your y would be this much. Are you getting my point? So what can we do? We can use our Ridge or Lazo. In Ridge and Lazo, the betas get shrink. So please a line note down karo that this linear regression is just for example purpose to showcase you that there is a problem of overfitting. सबको समझ में आया ना? There is a problem of overfitting. Now we'll apply our Ridge and Lazo. If I want, I could have directly applied the Ridge and Lazo, but I wanted you guys to realize that what is overfitting. Building Ridge and Lazo is very simple. Within 1 minute, it would be built from sklearn dot linear model, import Ridge regression. That's it. Ridge regression. I think I've done something wrong. And then the way you build the model will remain the same. We have already done the sampling, right? बस अब कुछ क्या करना है, कुछ नहीं करना है. Build your model as you have been building. DF train Y, DF train X. Predicted train and say Ridge. Predicted test. Can I say code at line number 431 is clear to everyone? The way we build a linear regression logistic, import your Ridge, create an instance, then run your fit function. predicted, then error train rich. Please आखिरी में वो rich word जरूर add कर देना, otherwise you would be very much confused. Make the conventions proper. So what is error? Error is nothing but actual minus predicted. So actual values will come from y. MSc test rich. सब कुछ जी कर देता हूँ यार. SQURE square. Now, सब लोग please यहाँ पे देखो. Can you notice the big improvement? MSc on train is 63. MSc on test is 79. Can you notice पहले ये कितना trillions में था ना? From that trillions, it has come down to 2 units. So now in your error in your train and test is almost equivalent. I'll not say almost equivalent, but it is in a range. Right? And do you also notice one thing? Do you know one thing? That I had said that error in your ridge would be more than your error in your linear. हम purposefully errors को increase कर देते हैं, right? So now in MSc in your test ridge, it has reduced from your trillions to just 2 units. Similarly, what I can do is I can find the MAPE train ridge, MAPE test ridge. So MAPE का formula क्या लगाया था हम लोग ने? This one. NP dot mean absolute NP dot error. Nans आ गया, इसमें कोई तो एक वैल्यू 0 आ गई इसमें. अच्छा हाँ, sorry, my mistake. 5.47. Now do you notice? Previously the MAPE was in millions. Now it has come to just 5.47. तुम लोग को सिर्फ एक ये लाइन देखनी है बस, बाकी सारी चीजें एक्सपेक्टेड है, यू विल डू ऑन योर ओन. but still I'm showing the code. Okay. सबका हो गया यहाँ तक?
Yes.
Right. So let's do our build our Lazo. See, building the Lazo is again same the way we have built our ridge. बस कुछ नहीं करना है. So I'll say from sklearn dot linear model import Lazo. That's it. खत्म. Lazo regression equal to Lazo. So this is your R square in your Lazo. R square has gone down even further. Lazo. Error train Lazo. Test Lazo. Okay. So guys, एक second वापस सब लोग please stop whatever you guys are doing. So what I have done, I have find the MSC in Lazo, train Lazo, and MSC in test Lazo. Do you notice? They are close by. So it means model is not overfitting. Compare it with your linear one. देख रहे हो MSC on your test data has decreased heavily, but probably MSC on your train data has increased. If you compare your MSC in Lazo with your MSC in your linear, MSC in linear कहाँ था? What was my MSC in linear? MSC in linear regression train was 63. MSC in linear regression was 63, but MSC in my test was infinite. Now you compare your MSC in train Lazo from 63, it has increased to 98. But on test, it has heavily decreased. Remember, error in Lazo would be more than your error in which? So on your train data, the errors are increasing, and if errors are increasing on train, chances of overfitting will automatically reduce. That is what is happening. And similarly, you can compare with your bridge also. MSC in your train, MSC in your train linear was how much? Something 63 kuch tha. It is almost similar over here. But MSC in test, it has reduced significantly. Again, once again, abhi koi kuch nahi karega. So all this code is very simple. If you want, I can put it on the chat also, no problem. I'm not doing anything. I'm just building. I'm just writing one line and then I'm doing my fit and scoring and everything. ठीक है, code में कुछ भी नहीं रखा. There's nothing new. Now, let's compare. Let's compare the beta or the coefficients of the three different models. Three different models. सब लोग प्लीज यहाँ पे ध्यान से देखो. So let me say data frame with coefficients. Data frame with coefficients. So एक empty data set create कर लेते हैं. Empty data frame pd.data frame. Then I'll say df coefficient and I'll say linear. Just lean कर देते हैं. Then let me say rich. Then let me say lasso. Now what I'll do is I'll say what was my model name? My model name was linear regression. Linear regression .coef. And name of my ridge model was क्या लिया था मैंने ridge model? Ridge underscore regression. And name of my lasso model was lasso regression. Now let's see here this data frame. पूरा ही देखो. So in linear regression, guys, do you notice, for example, let me take this value. This is a very large value. Ignore the minus sign. Again, I'm saying ignore the minus sign. So this is a very large value. It is in billions. But ridge and lasso mein dekh raha ho, it has become very small. Remember the coefficient, the beta values in your ridge and lassos get shrink. याद आ रहा है मैंने बताया था? They get shrink. In lasso they become exactly zeros also. So lasso में देख रहा हो कुछ values have exactly become zeros. And that is why lasso can be used for your feature selection, can be used for your feature selection. Can you notice so many values have become zeros? दिखता है कितने सारे values हैं जो zero हो गए. And both in ridge and lasso the beta values have shrink. Compare this numbers just for an example. So it is plus 10. So 10 crore, this is almost your 100 crore. और उसके सामने जो numbers आए हैं ridge and lasso, they are almost negligible. Can you notice? Let me do one thing. Let me say this. I just want to find कितने beta values dot Can you notice 370 beta values have become zero? दिखता है? I hope people understand this part of code. Right? So I am saying equal to 0. So how many records are there for which the lasso is 0? 370. How many total records do we have? Are nahi bhai. 376 x values. X values. You would be having, so only out of 376 x variables, now you can build your model using only 6 variables. Why? Because 370 have already become 0. तो feature selection हो गया. और इसको कुछ हम ऐसे भी कर सकते हैं कि let me say which all of them are not equal to 0. ये बाकी सब zeros हो गए. And that is why your lasso can be used for your feature selection. And if you notice, the betas have shrunk both in ridge and lasso. Now please go ahead and do whatever you want. I'll give you 5 minutes. That is how you build your ridge and lasso. And if you want, you can further investigate also. Done, guys? सबको कोड एट लाइन नंबर 458 समझ में आता है? 457 and 458, right? ना? It is already covered in pandas how to create a data frame and how to add a column to it, right? So there are many things which I'll stop to explain now. That would be my assumption that people understand. ये line किसने draw कर दी भाई? Okay.
Sir, can you scroll down?
So again, I'm repeating line number 461, 462, 3. They are just for explanation purpose. You may do it, you may not do it. These are just for your understanding purpose. Okay, guys, so with this, I'll end the session. And there is one more thing which I want to cover, but probably that we will cover tomorrow. That is VIF, variance inflation factor. Variance inflation factor. So this we will see tomorrow. कल कितने बजे class रखा है?
10:30.
10:30. 10:30. Let's meet. So tomorrow we'll see variance inflation factor. Probably this will take half an hour, and then we will see a boosting. बूस्टिंग में मैं एक तुम लोग को एडा बूस्ट बता दूंगा. This will take me somewhere around 30 minutes, and then we'll start with our NLP, natural language processing. ठीक है. Now this would be a very interesting area where we would be working on the unstructured data, text data पे काम कर रहे हैं. ठीक है. So try not to miss tomorrow's class, especially the NLP part, and we'll also see what is the VIF. Okay, guys. So with this, I'll end the session. Thank you for joining. And अब तुम लोग अपना break ले सकते हो.